afternoon. So we are here for the webinar AI in Healthcare. I welcome you all to this webinar. And today's topic is transforming medicine with artificial intelligence. When we talk about AI in healthcare, it's a very hot domain when it comes to artificial intelligence, right? So healthcare, we all know, is very important. And coming to healthcare along with AI plus healthcare is a deadly combination. We always talk about healthcare being the prime thing for all of us, right? Now, the basic question that goes for everyone is, how do we apply AI in healthcare? I mean, where do we apply in healthcare? Where would we applying that same? Today, we'll see what are the applications we have of AI in healthcare. We'll see different type of what are the challenges we have, right? We'll be talking about some of the projects that we've done at AI Spry that are in healthcare domains, right? I'll be explaining these projects. And yes, we will move further. And you will understand clearly how much important healthcare is. And AI in healthcare, why we say it's a very hot topic. So, talking for about agenda for today, we'll be talking about introduction to AI in healthcare. We'll be talking about AI applications in healthcare. We'll be talking about challenges and ethical considerations in healthcare. We'll be talking about future of AI in healthcare. When we are talking about AI applications in healthcare, we'll be talking about some of the projects that we have done related to healthcare itself. Now, there are three or four projects that I need to discuss or I intend to discuss. And yes, we'll be discussing the same. Right. Now, what is basically AI in healthcare? So, when we talk about artificial intelligence or use of artificial intelligence in healthcare, that just means use of machine learning, the traditional machine learning we talk about, use of deep learning, use of natural language processing or NLP, and computer vision to improve diagnosis, treatment, and healthcare operations. You must be thinking, okay, Bhupendra, that is good. By the way, yes, I didn't introduce myself. I'm Bhupendra Devangan, and I am a trainer. I'm a data scientist at ASPRI and of course a trainer at 360DigiTMG. Now, when we talk about all these things, you must be thinking what is the difference we have. When we talk about machine learning or deep learning, what are the differences we have? You know, AI is an overarching domain. AI is everything. Inside it, we have data science. Inside data science, we say we have data mining. Data mining has machine learning. Of course, machine learning is part of data mining. And we have deep learning. Okay, great. Then where is natural language processing and computer vision? Well, all these form the part of deep learning. When we talk about machine learning here, we talk about the structured data. We talk about the structured data. When we talk about deep learning, we talk about unstructured data. Now, what are the projects that are possible in deep learning and in machine learning? What are the projects that are possible? And what are these domains basically related to? For example, when we talk about deep learning, we'll be talking about images. We'll be talking about videos. We'll be talking about, again, natural language processing, right? a text data, for example, here, I should say text data, that would be better, right? Text data here in structured data, we talk about the data in rows and columns, right? The basic tabular data we have, that is the tabular data we have. So what would we do here? We would be improving the diagnosis, treatment, and healthcare operations. And how do we do that? How do we do that is something that we will see as we proceed further, right? Now, let me go further. Why is AI important in healthcare? Now, we all know AI is galloping in every domain like anything, right? So, what is so important to use in healthcare? I mean, it's all about just operating, right? Operations and all. No, of course not. When we talk about AI, we have so many things here, right? We have so many things to consider when we talk about AI and in healthcare. Well, talking about machines or artificial intelligence, we know it is much more accurate than human beings, right? If we deploy artificial intelligence in healthcare, we all know the chances of our survival will be much more, right? We can use AI for survival analytics. We can use AI or machine learning, for example, for inventory management, for basic forecasting of number of medicine that would be required, for any image related data. For example, we have tumors, right? We have tumor, for example, and in that you're looking at those tumor, we can understand if it's a benign tumor or malignant tumor, right? Talking about accuracy, of course, we will be doing it with much more accuracy. You can make chatbots using artificial intelligence for hospital management, right? When we talk about understanding these things, AI, for example, will be very, very cost effective, right? How it will be cost effective, we will be talking about that and we'll be enhancing the patient care, right? Now, first, faster diagnosis. AI can analyze medical scans in seconds, reducing diagnostic time. Now, consider that you have lot of medical scans, right? You have scanned images. You have given these images to the model. Basically, you did computer vision. You use computer vision. Here, you gave these images, and now the model knows whatever scan you're talking about. For example, you're talking about scan of lungs, right? Here, basically looking at it, for example, during COVID-19, we all know, right? Lungs, we all know where people were getting affected by pneumonia, and at the very same time, there was problem of all these things in lungs, right? The same thing can be easily understood by AI once we make the model here, right? So for example, if we say lungs images, you will actually mark, okay, these are the things, these are the damages we're talking about. And when we give it to model will understand what are the damages we have here, what are the good parts we have here, right? And accordingly, whenever we talk about it, it will do medical scanning. And it will do scanning and it will say how good the particular image is, right? So the diagnostic time would be very less. Think of it. You only have images, you give images to the model, and model says, okay, this is 80% good, this is 90% good, this is 95% good, right? That, for example, when you're doing sonography, for example, right? If you're doing that scanning, Slowly and steadily, you can actually understand if the growth of a child is proper or not. If the growth of a child in mother's womb is proper or not. Is there any issue? Is there any condition? Is there any problem with the same? Exactly. So faster diagnosis is possible. Second, we talk about improved accuracy, higher precision. Now think of it. Human beings actually know from their experience and they have seen limited images. Consider that the same thing, the medical scans you're talking about, you're taking these scans from so many centers, from so many countries, you're just annotating them or marking them properly. And yes, once you understand that, it will give a better precision than humans. It will be able to infer what is there in that particular photo, right? A particular scan, and along with much more precision. Third, we talk about cost effectiveness. Well, we all know we focus on cost effectiveness when it comes to medicines. It's something that is very, very cost intensive, right? It's medical field. We know once we start coming there, once we get health issues, it just goes on continuously, right? We need to make sure that if treatments that we are having are cost effective. So how do we do that? If accuracy is improved, diagnosis is faster, AI is doing everything, you don't need to invest much on the doctors itself, right? Of course, doctor will be guiding you, but at the very same time, what are the resources that you're using? For example, if you're going to a visit and if the doctor has to test, he will give you a lot of scans and all, right? He'll give you a lot of medicines that maybe for no reason would be, for sometimes it would be really good, or sometimes it's not even needed. Even then, he'll give you medicines. You will be taking a person's time, right? So you'll need to pay the person too. So the treatment that will have will be very much cost effective. Whatever unnecessary tests you have, that you will be avoiding. Hospital resources that you have, that will be optimized, right? So we have enhanced patient care. Of course, a patient, for example, has any issue or has anything in his mind, any question he has, what do? You come up with a chatbot. You come up with the chatbots. For example, we have a chatbot for every hospital. Chatbot or virtual assistants, you can say. What are we doing here? Patients, if they have any issue, they can talk to the chatbot itself, right? They don't need to wait for the doctor and then tell the doctor and then doctor telling them. No, if they have any issue, then and there you are getting answer, right? So that's the reason we have chatbots, virtual assistants. So whatever agony they have, whatever pain they have, they can clearly tell about that. If they are actually focused on something, they'll be talking about that. If they're worried about something, they can talk about that, right? And remote monitoring to improve patient experience rather than you disturbing patient again and again, right? And try to encourage in his personal space. Sometimes too much of interference is not needed, right? So if you are having minimum interference, also you are solving all the issues using chatbots, or chatbots are actually correct. There are assistants, virtual assistants who are there and who are answering to those questions. That will be really, really good. Don't you think that? Right. It is good, right? If we talk about DeepMind AI by Google, well, it is able to diagnose eye disease by analyzing the retinal scans, and it has 94% accuracy, right? And that is as comparable to top ophthalmologists. Ophthalmologists deal with eye care, eye disease, for example. And here you are able to tell that you are clearly able to give more accuracy than human beings. Isn't this awesome? Isn't it wonderful? It is right. Now, we understood why AI is important in healthcare. We'll talk about applications of AI. Once application part we reach to the end, we'll be talking about different projects that we worked on, or different type of projects that we can go through. Right now, AI in medical imaging and diagnosis. When we talk about medical imaging, the major area where AI is revolutionizing diagnosis through computer vision models. Computer vision. Now, what is computer vision? You must be thinking. Computer vision is basically a field of data science, a field of artificial intelligence that deals with the image data or videos. And what we do here? We do image analytics. Right. We give a lot of images. How it functions? We have a computer vision model. You give a lot of images to the model. And then once you give the model is trained here, and you give one more image, and you come up with the result for this particular image, because these images are training this. Right. Now, what are the use cases? For use cases, we have X-rays, MRIs, CT scans. Right. If you have to detect a fracture, right, maybe it's a hairline fracture, you're not able to see that. Right. AI can easily understand hairline fractures. So AI detects fractures, tumors, and abnormalities. Right. As we discussed, consider, let's talk about one of the projects we have. Right. Let me just go through the notepad. Now, in one of the projects that we did here, we had 569 patients data, and we had a lot of rows there. Right. We had a lot of rows. Approximately we had 32 rows, and we had 569 32 columns we had, and we had 569 rows. Using traditional machine learning, I'm not even talking about computer vision. We'll be talking about computer vision too. We have done that project in both the fields. Using traditional machine learning, we had to classify all the data into two parts. If the tumor we have is a benign one or a malignant one. Benign tumor, of course, is non-cancerous. Malignant tumor, whereas we say are cancerous. Right. Now, what we had here, we had different attributes. We had 32 columns here. We had different attributes. Based on those attributes, we gave to the model if a particular row, a particular data, for example, a particular patient we have is benign or malignant. Basically, ultimately, the model got trained. We did model training. And we came up with the web app. What we did in this web app, of course, you give all the information, you click on predict, and the web app will clearly take all the information, and it will come with the answer if the particular tumor is benign or malignant. This will be really helpful for the doctor. Right. For doctors, this is really a boon. Right. Now, the same process is what we have done in one of the projects. This was basically related to rows and columns. The next one we had related to the images. Now you must be thinking, okay, what about images? So for example, we had different tumors. For tumors, we had images, and that data sets we clearly classified into two parts. Either it's a benign tumor or it's a malignant tumor. In that case, if it's benign or malignant, we gave the image, and whenever to the model, of course, and whenever it gives the answer here, and whenever we give image to the model of benign or malignant tumor, it will clearly classify it into benign or malignant. Right. Now, this is one of the projects that we did. Let me take you back to the slides itself. Now, use in X-rays, MRI, CT scan to detect fractures, tumors we talked about, abnormalities if we have any, right? We talk about it. Second, pathology slides analysis. Now, AI spots cancerous cells in biopsy samples. Now, this is one of the projects that we did. That's the reason we mentioned it here. When we talk about cancerous cell, if the particular cell is a benign cell or a malignant cell, right? You'll do biopsy, you'll get a lot of images here, and you'll understand based on the data if it's benign or if it's malignant, right? Now, cardiac MRI segmentation, right? If, for example, there is any issue in the heart, right? If there's any issue in the heart, what will it detect? It will be able to detect that there is an issue in the heart based on the images we have of different hearts of same size or dimension, for example, or in general images of a heart. We will understand if there is a block in the heart, right? If there's any issue in the artery, right? If there's any issue in the heart itself, based on the images, right? So all these things will be covered. You are right. MRI segmentation we have, images data we have, we'll be using that, right? To diagnose early heart disease, right? If there's any issue, so that we can clearly tell the person itself that, okay, you may have heart disease in future, right? So next example, for example, if you see real life examples, of course, we have seen real life examples already. Stanford University developed ChexNet, the AI-powered model that can detect pneumonia in chest X-rays more accurately than human radiologists. We all know during second COVID, that is Delta wave during 2021, we all remember how problematic that was, right? People were searching for oxygens, and yes, there was issue because there was a problem, that variant problem, right? Delta variant it was, and it used to damage again liver and our lungs in a really bad way, right? Now, second, predictive analysis and disease forecasting, right? What will happen here? AI model will analyze the historical patient data. Whatever patient data you have, it will analyze that, and it will predict the disease before the disease occurs. It will clearly predict that you may be having this disease in future. You may have this disease in future, right? Why? Based on the the lifestyle, for example. Let's talk about the life care. I think it's a lifestyle itself. If the person is drinking water enough, if the person is smoking, if the person, for example, has any family issue, family issue, right? Or for anything, right? If there is, for example, too much of cholesterol in the body, right? All these things, if person has diabetes or not, and all those things we talk about lifestyle, right? Before the symptoms arrive, based on the lifestyle itself, we can give this example. Talking about use cases, of course, early detection of chronic disease, that is diabetes, heart disease, and all. Predicting patient deterioration in ICUs using vital signs data. Right? If there is a person who has some issues, of course, we can clearly predict if the health of the person would be good or not. Third, we say disease outbreak prediction. Disease outbreak prediction. For example, talking about COVID-19, AI had clearly identified all these things before World Health Organization declared it a pandemic. Right. Now, disease outbreak prediction can be done here using AI, predictive analysis. We used to predict, right? For example, if COVID-19 is restricted more towards city, right, we'll say that, okay, here there will be some problem, right? If this is spread in city, it may happen that it is spreading fast in another city too, because there are people who are moving from one city to another city, right? We all know there was COVID in China, and after that there was COVID in US. That was really good. I mean, not really good per se. The context is for that. For explaining that context is really good for us, right? So we can understand how the outbreak actually went. Now, IBM Watson Health uses AI-based predictive analytics to detect early signs of sepsis, improving ICU survival rates. Right. For example, if there's an issue with our immune system, there's problem of sepsis. Right. The survival will be really different or difficult, I should say. Now, use of artificial intelligence in drug discovery and deployment. Right. Now, talking about AI here, AI accelerates drug discovery by identifying potential compounds in days instead of years. Right. Whenever we talk about drug discovery, we all know making a drug discovery or coming up with a new drug takes time. It takes its own sweet time. Now, if you have to go for drug discovery, basically, what is the target of the particular drug? Right. What are the potential compounds that will be needed for that particular disease? All these things can be come up with using AI. That is one point. Another point, for example, if you have to come up with specialized drug means a drug that will be going and affecting those diseases itself. Right? Whatever diseases we have, it will be affecting those diseases, and the concentration that is required for that drug to basically make an impact on that disease or to cure that disease, everything will be predicted by using AI itself. Talking about molecule simulation, right? How molecules interact, reducing lab testing cost. How molecules react to that drug itself, right? How different is the relation of, or how different is the interaction of a drug with a normal molecule or a drug with the diseased molecule, right? If there's disease in a particular person, how is the response of a drug? That we can clearly understand. Second, we see is drug repurposing. Whatever drugs you have, we all know we have some limitations in understanding where they can be used. Now, when we talk about AI can actually help us in repurposing the drug. Right. For example, again, we can actually add new uses for existing drugs. For example, there's one medicine that actually used to cure heart attack, but at the very same time, that medicine was clearly promoting hair growth. So after that, after some point, people started using it for hair growth, right? Better hair growth. Now, talking about next, that is clinical trial optimization. AI selects ideal candidates, reducing trial failures. Whoever is the ideal candidate for basically trial optimization, that can be clearly seen here. Talking about the example, DeepMind's AlphaFold AI solved 50 years old protein folding problem, helping drug researchers to develop new treatment for diseases like Alzheimer and cancer. Right. Let me move to the next part. AI in personalized medicine and genomics. We talked about the same. Right. AI tailors treatments based on individual's genetic profile, improving effectiveness. Talking about use cases, you can actually have genetic based treatment recommendations for cancer and rare diseases. We have AI driven precision medicine platforms that suggest personalized drug and predicting patient response to medications using genetic data. Now, talking about example, we have IBM Watson Oncology. Oncology clearly analyzes cancer patients' genetic mutations. Right? What are the genetic mutations they have been through when they are cancer patients, and suggest personalized treatment options involving improving survival rates. Right? When we talk about this, we can actually go for personalized treatment options where we improve survival rates. Now, the basic problem is okay, and let me just before we proceed further with challenges and ethical consideration, let me just go back and explain you some of the projects that we have done here at AI Spry. One project that we have done related to medical field or medical or healthcare or pharmaceutical, for example, is medical inventory optimization. Now, what is medical inventory optimization, you may ask? Let's discuss about the same project. So, this project is related to healthcare and specifically related to pharmacy or pharmaceutical industry or pharmaceutical domain. Now, there is one client and a really good relation we have with Rela Hospital. Of course, we have it in Chennai. Right, that is a really good hospital. And we did for them a project called Medical Inventory Optimization. Now, you must be thinking, what is medical inventory optimization? What was the basic business problem the hospital had? Basic business problem, if we talk about, was that the bounce rate is increasing. Leading to patients' dissatisfaction. The bounce rate is increasing, leading to patients' dissatisfaction. Now, what is bounce rate here? Consider that you have a medical store and there is one person or patients come to you and they ask for some medicine. Right? When they ask for some medicine, you say you don't have that medicine. What the patient does? It bounces to another store. So the problem here was bounce rate is increasing, leading to patients' dissatisfaction. Right? If If a hospital doesn't have enough medicines or proper medicine, that will lead to patient dissatisfaction. What we needed to do here, we needed to maximize patient satisfaction. Of course, at the very same time, we had the challenge to minimize bounce rate, to minimize the bounce rate. Here, we have success criteria, for example, that okay, it should be more than 90% MAPE, right? I mean, MAPE should be less than 10% and all those things. Of course, we achieved that. And what is happening? What did we do here? First of all, we did a proper analysis, right? We went for business problem, business objective, business constraints. We have, again, 3 success criterias. We go for the next one, that is, again, we have complete process, right from making project charter, then researching and all those things, right? What we did here, we actually took the data from the client, we cleaned the data properly, and then we did forecasting. Of course, when we did forecasting, we clearly know, we came up with the number of drugs that would be required. Now there were many drugs, and we took, for example, we took top 10 drugs and we actually forecasted values for those drugs. Now, forecasting, of course, using different models, we had different models to try, and we did forecasting related to the same. Now, after this, after a problem and we did forecasting, we have another business problem. For example, we came up with 96% of accuracy, and we actually went further and deployed the model on AWS, right? One of the project that we did, and that was from traditional machine learning. The previous VC forecasting project was from traditional machine learning. Let's talk about another project that is again a traditional machine learning project related to survival analytics. What do we do here? When we talk about survival analytics, here we had the data. We had the data where we had all the columns or factors affecting kidney survival. We had different factors affecting kidney survival. And based on these factors, we needed to predict the survival of the graft. Right. Now, what was the business problem? Basically, the client had the problem, or a client had issue in selecting a proper kidney, a good kidney to graft. So, when we had the data, we took that data, of course, it had 52 columns and we had approximately 600 rows, right? 610 to be precise. 610 rows. And from this, we came up with the model. Of course, there were different variables. For example, if a person smokes or not, if a person drinks or not, what is the sodium level, what is the potassium level, what is the calcium level in the person's body, what is the blood pressure, what if the person has cardiac issue or not, if the person has diabetes or not, if the person smokes or not, drinks or not, if there is again, the person is exercising regularly or not, drinking enough water or not, right? There were many such factors that were affecting the same. And yes, we came up with the survival analytics problem. And yes, we gave the solution for how long a kidney may survive. The solution was to give the duration, for example, for how long the kidney may survive. We gave the proper survival analysis. We understood different factors and we came up with the answer. And of course, we deployed it in AWS. Now, this is one of the project. Third project we talk about is again related to generative AI. Till now, you saw two projects related to machine learning, traditional machine learning. Generative AI, if we talk about, there is something called startup. It's basically a chatbot. And who was the client? Again, Rela Hospital was the client after a success in the medical inventory optimization project. Now, this was done using LLM or large language models. Startup. Basically, as we discussed, this was a chatbot, and we had different information. Talk about the chatbot here. We had all the information from different domain. What you needed to do is ask questions, and it used to come up with the response, right? Basically related to procedure, basically related to uh, the governance, or to related to medical reports or anything. Everything was present in the startup, right? Now, fourth project we talk about is basically a project related to embryo. We call it embryo project. Of course, we have our own names for those projects, embryo projects. The client is GBR here. This is in Chennai. Now, in this embryo project, we have basically what are we trying to achieve here? In embryo project, we want to make sure that we select the best embryo possible for healthy pregnancy. Now consider, when we all know how much pregnancy is important, and we know that to make sure that a couple has healthy pregnancy, if they get a chance to choose all the food, all the features we have, and based on those features, whatever is the healthy embryo, if the couple gets a chance to select that type of embryo, won't that be super duper awesome? Won't that be super duper good? It will be, right? Exactly. So when we talk about embryo project, this was basically related to CNN, where we actually improved the chances of healthy pregnancy. Just because we were able to clearly monitor what are the factors that are affecting the same, right? Now, this is one of the project that we have done here. Now, next talking about one more project, the fifth project. We talked about medical inventory optimization. We talked about the graph survival project. We talked about the computer vision project that is related to embryo selection. We talked about a Gen AI project that is related to setup. Right. One more project, for example. Consider when we talk about waist circumference. Basically, now this project was related to cardiac diseases, or talk about fifth project. Basically, it is related to cardiac diseases. Now, what did we do? We generally say that there is adipose tissue. Adipose tissue is just fat we are talking about, the body fat we talk about. Adipose tissue. And the second one is waist circumference. It is generally believed that if the waist circumference is more, chances of cardiac diseases is higher based on the waist circumference. Now, we wanted to see the relation between adipose tissue and waist circumference. And what we did, we used linear regression here. We use linear regression here to make sure that we come up with amount of adipose tissue that is in turn based on the waist circumference, right? So more is the waist circumference, more is the adipose tissue, and more is the adipose tissue, more is the chances of cardiac diseases, right? This is what we had as one of the projects. Now we have discussed total 5 projects, and I believe you might have got a clear understanding of what do we do in what do we do really in medical domain or in healthcare domain. Now let's come back to the slide itself. Let's talk about different challenges we have here. Now, talking about challenges and ethical considerations, the biggest challenge, the biggest problem we face here is data privacy. Right. Now, data privacy and security concern is a big issue. We all know the medical data that we have is sensitive data. Right. Sensitive data, patient's data. Right. So when we talk about confidentiality, patient's confidentiality, that is really in a hospital's hand when we talk about security and all, right? The complete patient data can be leaked, and that can be used for the advantage or for the disadvantage of a patient, right? Now, this is one big issue. So that's the reason security concerns are very much needed, are very much clear that we have security concerns and we still have that risk while dealing with these things. Now, solution to the same, of course, we use, here, let me clear this. We use HIPAA compliant AI solution to protect patient record, right? We make sure that we have all the records properly, right? And again, are not shared like anything, right? We can implement blockchain for secure patient data sharing. If you have patient data, you can use blockchain to make sure that it is very much secure. Now, talking about one of the examples in 2019, Google AI Health partnership with Ascension sparked concerns over unauthorized patient data sharing. Now, we all understand that whenever we are talking about these things, whenever we are talking about Google coming in collaboration with a company that is having data. We all know when we Google search, when we search something, after some time, you are able to assess those ads, or you are able to see those ads that are actually related to whatever you have searched. So we can clearly understand that there is a clear relation between that, right? So when we talk about partnership with one of the, again, hospitals and one of the leading medical center, there is a big problem of unauthorized data sharing, right? And this happens very much, and this is a big concern. Bias in AI and fairness in decision making. When we talk about AI models that are trained on biased data set may lead to inaccurate diagnosis for a specific population. For example, if we talk about skin disease, well, this is one of the projects that we are doing even now. We talk about skin disease here. If this skin disease project or the data set we have is of white people, right? If the skin disease data set we have is of white people only, or for someone who is having white skin only, then that would be the issue, that the algorithm won't be able to identify if the same problem, if the someone who's a bit dark in color or brown in color would be operating the same, right? So the diagnosis we talk about won't be proper. So talking about solution, you need to make sure that the AI devices you're training or the AI models you're training should be trained on diverse representative data sets. Of course, there needs to be regular audits to reduce racial, gender, and socioeconomic biases. Right? If there's any racial, gender, or socioeconomic bias, we need to make sure that we reduce it. We need to train on the diverse data and representative data sets. Example, in 2019, a study found that AI model for skin cancer detection was less accurate for dark-skinned individuals. This is what we were discussing, right? And this is what impacts the credibility that people have on AI, right? AI loses its credibility because of such inaccurate diagnosis, because of such biased data sets. Now, this was one concern. Talking about interpretability and transparency in AI, we all know when we talk about AI, it's a black box technique. We have no idea. We can see the input and output, but we have no idea when it comes to decision making. Why is it making the decision? You can see the output, but why it gave the output is something that is not known. Black box, we call it, right? So doctors generally hesitate to trust the black box AI models with no explanation of their prediction. Why is something predicted if it is predicted, right? What we see as solution? Well, huge research is going on explainable AI, XAI for decision transparency, right? We need to implement human AI collaboration rather than full automation. We can't go for 100% AI, right? We need to make sure that we have human involvement in there, right? Rather than going for full automation. Also, talking about example, IBM Watson struggled to gain doctors' trust due to lack of explainability in AI generated cancer treatment recommendation. For example, doctors were not clear why this type of steps or this type of recommendations are given by AI. Even now, explainable AI is in its nascent stage, still in research phase, right? When we talk about AI, explainability is what matters to the clients too, right? Now, Talking about the next part, future of AI in healthcare. When I talk about AI, of course, AI plus Internet of Things we talk about. You have, for example, if you have a wearable health monitoring system, if you have a wearable device that can monitor your heart rate, blood sugar, oxygen level, right? Everything, the steps of your walking and all those things. If there is an emergency, if there is some discrepancy in the data, doctors would be alerted. And yes, this particular thing will actually help in alerting in terms of emergencies. Now think of it. One of the recent examples that was in news, in fact, few weeks ago, was related to a patient or a person who met with an accident. Now, there was no one to detect that there was an accident or not. He was all alone. But again, what happened? He was wearing the Apple Watch, right? When the person fell, Apple Watch detected that the person fell, and thus it just automatically gave call to the emergency, right? Now, because of that, everyone was alerted, and that particular person was saved. Think of it. Isn't this a really good use of AI in healthcare to save person's life? It is right. It is indeed a really good approach. Example here, if you see, we have Apple Watch. Apple Watch ECG features detect early signs of arterial fibrillation, right? Preventing strokes. If there's any chances of any strokes that will be prevented. Talking about robotic surgery, of course, we can go for AI-driven robotic surgery systems to improve precision, reducing errors, right? For example, Da Vinci surgical system enables minimally invasive procedures with AI-assisted precision control, right? Minimal invasive procedure. You don't need to do any type of surgery. Talking about physical health is done, but at the very same time, mental health is also being offered by AI. When we talk about AI-powered chatbots, they offer therapy. They detect depression and provide early mental health intervention. Right? That is really good. Mental health is a one big thing nowadays. We bought an AI chatbot provides CBT based surgery therapy based therapy for anxiety and depression. Right. Now, let's move to the next part. Talking about generative AI in medical research, generative AI synthesizes new medical images for training AI models and assists in scientific literature reviews. Again, ChatGPT, for example, is also really very good. AI generated synthetic MRIs helped train medical AI without violating patients' privacy. Right. If you want to train an AI model, if it's generated directly, synthetically, or using generators and discriminators, right? Autoencoders EPC. So again, if you use them, it will be really very useful, right? Talking about key takeaways, well, AI is transforming diagnosis, treatment, and operations in healthcare. And we have seen it beautifully. We covered a lot of examples, lot of projects that we are doing here. Despite challenges, AI-driven innovations enhance patient care and they reduce cost. Right. Now, talking about future advancements in AI, it will have personalized medicine, improve mental health care, and revolutionize surgeries. Right. Now, we all know AI in healthcare will be a boon, is already a boon, and will be a boon too. We have some considerations, and ones that are overcome. For example, explainable AI comes into picture. If AI is able to explain itself, what are the decisions that it is taking, what is the logic behind its own decision, we will be moving towards a safer future with AI in healthcare, right? So, thank you so much for your time, team. Thank you so much for being here and listening to the session. And I hope you learned a lot of things here and you gained something very important from this session. So, thank you so much for your time, team. And we'll stop the session here itself and we'll meet again later. And yes, till that time, happy learning, team. Take care. Bye.